Good day, everybody. We are back once again. I hope you are fine. So welcome back, Retors. Today we're doing functions and inverses. So now function is when an element of one set maps into one and only one element of another set. So what do I mean by that? It in simpler terms, it is when one x value gives only one y value. Is it fine? That's how it is. So now we are just gonna get straight to the point. Now in this topic we have what you call the horizon. We have the what you call the, let me start here with the two types of functions. So two types of functions. Number one, we have what? One to one function, whereby this one is just a clear function, okay, whereby the graph it is a function. Then you have what? Many to one function. Is it fine? So now under the very same thing, let's continue and do what you call our horizontal and what? Vertical line tests. So now these are the lines that we checked in order that the what you call, we use the test lines in order to check if a graph is a function or not. So now they are what? Dots, as you can see, like asymptotes. So now basically what is happening here is that we use this horizontal and vertical line test to check whether a graph is a function or not a function. So by drawing a vertical or horizontal line, it must cut the graph once. So if it is cutting the graph once, therefore the graph will be what? A function. And then if it cuts the graph twice or more, then it is not a function. So twice or more, so it is what? Not a function. Okay, yeah, you see that? No, it is not a function. So now let's start. What if I have this example here? So now let's say I have my line here, straight line, which is like that. So basically this is x, this is y, this is x. So now when we are doing the vertical or horizontal line test, we usually start with the vertical line test first, because it is always the one that determines our thing. So basically it is cutting the graph where the ones, meaning that this one is what? Is a function. Is it fine? That's how it is with this thing. So now even if we have what to call another example, we can have our parabola, which is something like this, and we start with the vertical one. As you can see, this one is a what? Is a what to call, is a function, because it is cutting this graph where once. And then if we have a parabola, but a parabola which is like this, and then we check the vertical one, as you can see, this one is what? Is not a function, because it is cutting the graph twice. Okay, that's all it is with the what? With the vertical line test. Is it fine? So now let's continue now and do the real thing that we had to do today. Now let's go to what? Inverses. So now the inverses are functions that are reflected about the line y it is equals to x. Is it fine? The line exists between, like this, it is always like that, between the line y equals to x. It exists between the two graphs, or between graphs. Is it fine? So now if you can now check, we have three types of functions. We have the exponential one, exponential functions, whereby y it is equals to a to the power of x. Now number two, we have what? The what you call the parabola, whereby we have y it is equals to ax squared. And then last but not least, we have what? The straight line, which is what? Y it is equals to mx plus c. Okay, so now let's go to what? Steps to finding an inverse. So now number one, you do what? You swap x and y. Is it fine? Then number two, you do what? You make y the subject of the formula. Is it fine? So now, as you can see, that those are the steps for making what? For finding an inverse. Number one, you swap x and y. Then number two, you make y the subject. Is it fine? So now, what is the notation of an inverse? The notation of an inverse is this one. So it will be this one. So if our original graph it is f of x, therefore the inverse will be that notation. Okay, so now this notation indicates the inverse of one-to-one function, and then it is the reflection about the y equals to x as the same as the one for the inverse. Okay, now without wasting time, let's go to talk about what you call the range and the domain. So now this one will having what? A function and in its inverse. So we will have a function here and have what? Inverse here. Is it fine? So now we'll have domain, range, then domain, range. So now what you have to know, this is what I just illustrated. What do I mean by that? The domain of the domain of the original function is the same as the range of an inverse of this function. It's tricky, né? So now basically, if for example, let me take what you call the range of a parabola, whereby the parabola is maybe positive. So you know what it will be, y it is greater or equals to, maybe let's say the turning point is -4, the y value of the turning point is -4. So if the range of a parabola of f of x, né, it is y is greater or equals to -4, then the range of let's go to the inverse now. The domain of an inverse is gonna be this one. Can you understand it? So now we are just talking about inverse. We are simply swapping things. So if the range of a parabola is that one, then the domain of that parabola is the very same one. I hope you understand it there. Okay, that's how it is. We are simply doing what you call the inverse there. Just making an example about what you call the parabola, because it's the only example, a clear example that I can use there. Mara, even other functions, it works. Let me take another page and show you what I'm talking about. Okay, so now let's say we have a parabola, né? And then the range of this parabola, remember this one is an original graph, f of x, né? Then the range, it is what? Y it is greater or equals to -4. And then what is the domain? You know the domain, it is simply x element of real numbers. Then now let's go to the range and domain of its inverse of this, the inverse of this parabola. So now the range, now it will be what? Y element of real numbers. We are simply taking that one, guys. We are simply taking that one and just interchanging things. Is it fine? That's how it is, guys. And then now, what is going to be the domain now of this inverse? The domain, it is going to be x greater or equals to -4, because remember, a range is set of y values, the domain is set of x values. So do not make a mistake and write x element of real numbers. No, you are just swapping things, because range is a set of y values, x is what? The domain. So that's how it is, guys, with the thing. So now let me go to what you call the exponential graph. Is it fine? So let's start with the what? Exponential graph. So now to find an inverse of this exponential graph, let's see if y it is equals to a to the power of x. Do what? Swap x and y. So x it is equals to a to the power of y. And then after, you have to make what? Y the subject. So now we are going to introduce what? Logarithms. Okay, so basically this is what is going to happen. Sorry, this is what is going to happen now. Now we are going to have what? A log, let me say equals to here, né? So now we're having log a and then x equals to y. This is a base which is a. So it is simply log base a and then x here. Is it fine? That is what the inverse of this exponential graph. So even if we can simplify it, we usually do the method of what you call push, whereby we say this a takes x as a base that set and raises y. So now let's go and talk about the range and domain of this thing. So now check y it is equals to a to the power of x is a what? Is a original function, right? And then now the inverse is y it is equals to log a and then x. So now what is the domain? The domain it is simply x element of real numbers, and then the range it is what? Y it is greater than 0. Is it fine? And then remember I said you're gonna swap them. So now the domain of the inverse of this graph will be the range of this graph. The domain of this original graph, meaning that here we're gonna have what? X it is what? Greater than 0. Can you see it? And then the range of an inverse is gonna be the domain of that rim. As you can see, you are crossing, so it will be y element of real numbers. Can you see, or it's the same thing? Because here, if you can check what you just did there, guys, is it fine? That's how it is with the range and the domain. Now can you see it? Now let's continue with the what you call the lesson. Now the lesson. So now let's go again. Now we are gonna do what? Check the graph. So now if it happens that our graph which is given is like this, whereby it is going up there, and then here we have maybe 0 and 1. Then let's say they want us to find the inverse. Remember the inverse is across this line y equals to x. Then the inverse is gonna simply be what? 1 and 0, because we are simply doing what? Across the line equals to y equals to x. So now it is 1 and 0. The original one was 0 and 1. Now the inverse is what? 1 and 0. That's how it is. So basically here this graph is for y it is equals to log a and then x. Can you see it? And then this one is for y it is equals to a to the power of x. Do you understand the difference now? That's how it is, guys, with the graph. So now we can simply go to the next one and do what? Parabola. So now on the second one, parabola, you know what the original equation it is what? Y it is equals to ax squared. Number one, you do what? Swap x and y. So x is equals to a y squared. Divide both sides by a. Therefore y is going to be equals to plus or minus x over a, because I need to are talking about what? A square root. So now, but now this is what we have to know. This is an inverse, right? This is an original function, but there are some things that you'll have to take note there. Okay, so before you can continue, let me show you the graph. So now the graph of ax squared it is something like this. Okay, and then the graph of the inverse of that one it is like that. Can you see the difference now? This one is y it is equals to ax squared, and then this one is y equals to plus or minus root of x over a. Can you see it? And they are reflected across the what? The line y equals to this. So now you can just mix them. But please take note, Woti, this thing is not a function. For the inverse to be a function, every x value should have one corresponding y value. Remember the definition I gave you there at the end of introduction there. So now this is called the one-to-one function. Therefore, we need to do what? A restriction and restrict it. So how are you gonna do it? It's either you will say x is greater or equals to 0, or x is less than or equals to 0. That's how we restrict it. To check if a graph is a function, it needs to pass a vertical line test, where a vertical line is drawn on the graph, and if the line touch or intersect the graph at one point, therefore that one is a function. Remember I told you that for a graph to be a function, it must cut, the vertical line test must cut one point. So now we are gonna continue again. Let's talk about the vertical line test. So now we have this thing we are given. So now this is our y is equals to ax squared. Then let's check our vertical line. So as you can see, the vertical line is cutting the graph at one place. Can you see it? And then let's check the inverse. I showed you the inverse of this graph, and I even told you that you must always start using what? The vertical line test to check if a graph is a function or not. So as you can see, this one is not a function because it is cutting to more than 2 points. Is it fine? So now we'll have to restrict it. And then if x it is greater or equals to 0, this is how it must be. Now it is gonna be this one and that one. So now basically that is when we have restricted it, because this is what? A condition. We have restricted it. So basically this one must be the line where it is equals to x. So this one is just like a fish, if you can just check it now. Okay, so now again we will have what? When x is less than or equals to 0. So this is what we'll have. So now we'll be having this and that. Can you see it? That's how it is. So now this one is the inverse, this one is the what? Is the original graph. But at the same time, oh, this one, hey, it must go up there. It must go up there. It must be like this and then go up there. So basically you can maybe call it a bed or something. But now that's how we make sure that we restrict this thing from being restricted or even this thing a function. So for example, if maybe let's check the straight line, but the straight line is nothing much. So if let's say we have y it is equals to 2x plus 5, interchange x is equals to 2y plus 5, then take 5 to the other side, x minus 5 equals to 2y, then divide by 2. So therefore y it is equals to x minus 5 over 2. It can be even written as 1 over 2x minus 5 over 2, and this one is the inverse notation. Can you see it? That's how it is with the inverse, guys. I hope you have enjoyed and understood each and everything about the inverses, guys. Thank you very much.